Hey everyone. Let's talk about integers today in Java or any programming language, right? We know what integer is. We know how to add integers, do some maths around it, and add some logic and all. But I think we can go deeper than that and actually see what happens when you say, integer 42 and you want to add some numbers to 42 and things like that. So I have a quick very small demo and an animation to go through to show you when you type integer and run your program, how far does it go and how does it travel all the way to the CPU. So let me start sharing my screen here. Ready? All right, so this is a main method, and I'm using Java for the demo. So let's say integer I equals to 42, integer j equals to I plus 25, some random numbers, right? We run the program. Uh, Alrighty, so for now I'm just gonna use this out, and I run this program, and then I get the total count. Of what we wanted to do. Um, but behind the scene, there's a quite a bit of journey that this integer I, integer j has to make for us to see this on the console actually. Now, yeah, we got the number 67, right? So yeah, but like we really don't need to focus on this because most of our programming they really don't deal with heavy CPU intensive tasks, um, handling billions of requests daily and all, right? But let's say if you were to work with Google or Microsoft or some even trading companies, I think it does play a factor, and especially for the gamings actually. Gamings and there's more, right? Like password decryptions side of things and all. That's the reason, like, we now require passwords to be at least 15. Obviously, they are like they are in string or character or whichever way it's programmed. But by the end of the day, it's math there. But yeah, um, I just cannot show you this the CPU reading and JVM from this code itself. So I have a small animation that I combined together, and uh, and we can go through that and see how actually integer I is read by the CPU in the language of computer itself. All right, so imagine this is some 42-year-old guy, and his name was integer, let's say, and he wants to start his journey all the way to CPU so that they can understand him or her, but but you get the point, right? So let's say integer 42 is starting a journey. So what happens? First thing was um, this is the first code in a sense it's a cosmetic side of things, right? It's a plain English integer number 42. We write our code in the Java file, which is the Java. Um, Now, when this file is written, what happens next is, all right, let's do that again. This animation has a slight bug, but that's fine. I just have to hit reset. Okay, then the next thing that happens is the Java compiler that sits right above the JVM class loader. So, yeah, but I've noticed that a lot of people think that JVM and compiler kind of are in the same place, but it's always a compiler, and I think it applies to any other programming language. Something has to speak your language, kind of sense, right? So that way it understands where to send that. But anyway, so the Java compiler compiles your Java file and stores in the simplified version that compiler understands. So it's gonna rename it as bypuss 42, um, and then push that into the stack. So this is an integer, so it will be pushed into stack. If it was object, it would be in a heap. Um, but the concept applies same. Now um, now the Java compiler compiles your Java code, and that way it's platform independent because it's at bytecode instructions, right? Not at the bytes level, but at the bytecode instructions level. So these are two different things, which I'll talk later in some other videos. Um, and since I have this bug on this animation, this animation is nothing but some HTML, CSS, and React code and some ChatGPT help that I took from to build this up. But okay, so let's see where we are. Yeah, we already covered JVM, Java compiler, right? So now once the compiled bytecode instructions are completed, it is then loaded into class loader. Now class loader will load our .class file. And also one thing you could do, let's say you have a jar file, war file, right? Feel free to unzip those, and you'll actually see the file with the extension at .class. And I really recommend you to do that. That way you get the feeling that, hey, oh, okay, so I see these .class file were ready to be loaded into JVM. Now JVM for security reasons, it has its own check and several other things. So it checks for the validity of the bytecode, and then it prepares for the execution. All right, let's see. It goes down. Okay, well, it's restarted, but okay, JVM Class Loader. I already talked about JVM stack frame. Okay, let's pause here. Right, so this number 42 was stacked. Now it has its own sort of mapping that knows where it's stacked, um, and some metadata on it. And then based on that, it's going to pull other information when it's needed to. But now going to bytecode interpreter. So this bytecode interpreter, what it actually does is it has a way to manipulate it, like manipulate in a sense, not change the content of it, but do what we have asked, right? So previously here I have asked, hey, I want to add numbers, so it's gonna add numbers, subtract, division, and all. And also bytecode interpreter will make sure that the whatever it's sending to the just-in-time compiler, or we call it hotspot, that it can actually execute it. So it does not run into any threading logs or anything along the lines. Um, because at that point, yeah, let it go. Yeah. So we already talked about JVM stack frame. We just talked about bytecode interpreter. Now this just-in-time compiler, right? What it does is optimizes the bytecode, and then also just-in-time compiler, it has its unique algorithm that knows what machine it is running on. That knows. I mean to say this. So it knows what type of CPU it's using, what type of all that thing, the compute, what type of compute it needs, and it's at the assembly level kind of thing, right? So it knows if you're using some Intel, let's say I'm using Core i7, so it has its own properties, which I do not know in detail, but just-in-time compiler, which is JIT, knows how it should be executed. So now, and this is something for really needed for for performance and all. Um, and yeah, there's several chips company that just focus on these things, but at a very high level, we need to be aware of these. And also one other thing I've noticed in is usually we think like, hey, I read a Java source code, I compile that, and then we once we compile it, we have just-in-time compiler. But I think we should not forget about the JVM class loader and then stacking of those. Bytecode interpreter can be kind of skipped, but good to know. Now, um, let me just reset this one. I know you can obviously see this whole thing, but it's kind of scattered out. So let's see where we are. Let's do the start journey. Okay, Java source code, Java compiler. Yeah, this is kind of redundant for this demo, but uh, sometimes being redundant is good. That way, you can recall what you are saying here, and I can for next time make sure I don't have to fix this bug. Okay, now here we are. Okay, so now it's time to store that value in zeros and ones. Well, not just yet, but so these are the registers, right? The CPU registers and ALU is what you are seeing. So the one you are seeing 2A are hexadecimal values. It still hasn't been converted to zeros and ones completely. And this is ALU ready, meanings and or not. I'm not sure, but I'll have to like Google it on this one. ALU has to do with the operations like false with false is false, false with true is false, true with and all those logic that we run, right? And it will have that ready. Um, you can think of an if-else condition. If you can think of an for loop, this is where it gets stored in. It says, hey, this is what we are doing. This is what we are doing, but this is the logic they want you to run this through. All right. So now once the CPU execution is registered, and then the CPU will know what type of math it has to do. I'm not that smart to know how they do the math here. The CPU registers work. Uh, but yeah, now the final step would be um, the memory representation, right? So now how would the memory be represented? Oh wow, okay, now the bug is not a bug anymore, I guess. All right, there you go. Yeah, so now what? Okay. I guess not. It's still a bug. Oh geez. Okay. All right, there you go. Now to a final resting place, kind of, right? Now this particular number, that integer that we typed it in, will be put in a bit format, 32-bit representation at a memory level. So yeah, there you go. This is the journey and integer text for it to be understood by a machine. Without this, it will just be a text and not understood. And it doesn't really have to be what do you say integer only, right? It can be a string or anything. any for loop, and I'm very certain that the same processes apply for any language, whether it be even the front end, even Angular, for example. I think Angular by the end of the day actually has some. Obviously, it wouldn't have Java compiler, JVM Class Loader, JVM Stack Frame, but I believe it starts. I think C plus plus or something, for example, that has an interpreter that interprets Angular. Will obviously has to go through bytecode interpreter just in time compiling. I'm not sure fully on this one how it does, but obviously everything has to go through CPU execution, and obviously it will have its memory representation somewhere. All right, there you have it. And once again, thank you for staying all the way into the end of this video. And you guys have a great day, night, morning, wherever you are watching this video from. Thank you.